Good evening to all. In this lecture series about heat treatment, previous video we have spoken about the basic heat treatment, purpose and its advantages. Now in this video we are going to see the first type of annealing, first type of heat treatment, which is known as annealing. In this annealing, it's a heat treatment process used in the metallurgy to alter the properties of metals, typically to make them more workable or to relieve internal stresses. This process involves heating the metal to a specific temperature, holding the temperature for a period of time, and then it is gradually cooled in a controlled manner. So this gradually cooled, if it comes into the picture, we have many cooling methods, but especially for annealing, the cooling is done in furnace itself. So here we can break down this annealing into steps. The first step is heating. Here the metal is heated to a temperature above its recrystallization temperature. So every metal has its recrystallization temperature below the melting point. For example, if we take iron, its melting point is around 1400 degrees Celsius, but its recrystallization temperature is around 730 degrees Celsius. So this recrystallization comes into the picture where the crystals are rearranged, or you can say rebirth of crystals that takes place. This temperature varies depend upon the type of material and its specific properties. So this heating is typically done in furnace, and the temperature is carefully controlled to ensure a uniform heating is done throughout the metal. If the uniform heating is not done, then there may be many serious issues like the formation of cracks, warpages, etc. So the next step after heating is that soaking. Once the metal reaches the desired temperature, it should be held at the temperature for a period of time to allow for a uniform heating throughout the material. As I said earlier, uniform heating is the most important thing is in this heat treatment process. So homogeneous heating should be allowed, and it is most important. If it is not happening, then there may be a lot of stress creations inside the metal. So the soaking time is important to ensure that the desired metallurgical changes takes place. As we all know, until if you heat any material, the material will get expanded. So until otherwise the material is expanding, you can see the heat prevails. So at the same way, soaking where the material properties are get altered. After the soaking process, we have the next process and final process, which is known as cooling. The metal is slowly cooled down to the room temperature. Here the cooling rate is often controlled to achieve specific properties in a metal. So the slow cooling rates can result in softer and more ductile metal, while the faster cooling rates produces harder and more brittle material. Due to the slow cooling, you can see the grains growth occurs, so that due to this growth there may be formation of large grain size, so that the material gets softened. So the exact temperature, soaking time, and the cooling rate used in annealing process depends on the factor such as types of metal, its composition means chemical composition, like if we take a steel, you can see ferrous, carbon, silicon, manganese, sulfur, phosphorus, chromium, nickel, etc. That is the chemical composition and the desired properties of the finished product. The annealing can be used to soften metal, improve its machinability, relieve internal stress, and refine its microstructure. So it's a crucial process. As I said earlier, this is a very crucial process in metallurgy, and it is widely used in many industries such as manufacturing, automotives, aerospace, constructions. If you want to alter the property of any material, major if you are going to relieve the stress of any material, annealing is one of the best way to do it. Okay, that's all for this about annealing. Thank you and have a great day.